Okay, transformations of graphs. That is a fancy way of saying we're taking a parent function and we're moving it up and down and left and right, and we're stretching and compressing it. So we did quite a bit of that in our Math 3 classes. So we will try to bring back what's lodged in the deep recesses of your memory. So we always have our function, and today it's going to be everything from square root to cubic to absolute value. They're going to throw them all at you, and that's maybe why this lesson will be a little bit challenging. And then we've got to remember what these all do. All right, the k, so if it's on the outside of your function. And what I mean by that, like if I have the absolute value of x plus 3, it's not inside the absolute value. So if it's on the outside, this moves us up and down. If it's positive, it goes up. If it's negative, it goes down. And then this h, if it's inside your function, like we've got an x minus 3, it's inside the function this time. It moves it left and right, but key difference here. It's always opposite of the sign. So if it's a negative, it goes right. If it's a positive, it goes left. Okay. Multiplying at the head of your function makes it fat or skinny. So stretch or compress is how we say that. If it's bigger than 1, it stretches it. It's going to make it skinny, more narrow, okay? If it's a fraction in between 0 and 1, it looks like it's been smushed. It starts to flatten it a little bit. Now, something we did not focus on last year is if we have a value multiplied inside with x. That's something we never, ever, ever focused on. And it gives us a horizontal stretch and compress. And we'll talk about it. So it's going to squish you this way, right? And I'll show you how that works when we're graphing in a little bit. You know about this one. This just flips us upside down. But this one here flips left to right. And really our vocabulary here is, if it's out here, it flips on the x-axis, it brings us down here. If it's in here, it flips across the y-axis. And you guys are going to get lots of practice with this today. That's just kind of a summary. So we're going to do a couple of ALEKS problems together later. Hold on to this. You need to go in that order to get them right. So hold on to that. That will be something you want to have memorized before you go into your test on Friday, okay? I'm pretty sure that is not on your fact sheet. Okay, absolute value. Do you guys remember what it looks like? It's been a long time. Okay, good. It's a V. It's one of those. So our parent function sits here, and then we were over 1, up 1, over 2, up 2, and it was reflected on the other side. Now, my transformations of graphs, the way I taught you guys, were always based on the parent function, okay? So that's why I'm going to kind of refresh your memory on these as we go. And then you don't have to create tables and plug in values because that gets lengthy. If you don't remember the parent function, do this, okay? All right, so this is the parent function right here. Parent function of absolute value of x. What does that negative do to our v? Everybody talk about it. Where does it flip it? Just upside down, right? Oh man, that's so tiny. So if I know my parent function, I can just move it around. Give you some time to finish up your notes on that one. Okay. Next. All right. X squared. What does our parent function look like? So here is our x squared parent function. It also sits at 0, 0. Okay, what's 1 squared? 1. What's 2 squared? 2, 3, 4. 2, 3, 4. And then it is symmetric, so it's balanced on the other side. So here is our parent function. And what was our pattern from the vertex? We were over 1, up 1, and then it was what? Yeah, over 2, up 4. And the way to remember that is 2 squared is 4. 1 squared is 1, right? Okay, so let's remember what these do. I'll shut up for a second. You're still getting that parent function in there. What does the minus 5 do to that parent function? Down. And does anybody remember how we talked about the 2 times? Bigger, how so? It is. It's going to stretch it up, right? And so we talked about, just making sure that was in the window there. We multiply the up is kind of what we called. So we multiply the y. So we are going to go down 5, and that is here. 1, 2, 3, 4, 5. Parent function was over 1, up 1. Our y direction is 1. So we're going to go over 1, up 1 times 2, which is 2. Reflected on the other side. Over 2, up 4, becomes over 2. 4 times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. Reflected on the other side. I have to make the dots really big so my function goes through them. Questions on that? I'm sure there are, so it's a great time to ask. Okay, same parent function, yes? This one is going up 2, and how about this guy in here? Right 5. So I can just take my vertex and I'm going to move it right 5 and up 2. There's no stretch or compress. So 1 squared is 1, 2 squared is 4. Reflect it on the other side. I need bigger graphs. I don't know about you guys. That's hard for me. Do parabolas come crashing back? Good. Ooh, uh-oh, my marker bled through. You guys are going to have to ignore some green dots there. Maybe I'll use a different color on this one because of that. Square root function. Does anybody remember that parent function? Square root of x, parent function. My marker is drying out. Let me grab a different one. Ooh. It starts at 0, 0. What's the square root of 1? 1. What's the next number that we can take a nice, pretty square root of? What's the square root of 4? So over 4 up to, how many points does it want? The leftmost point and 3 additional. So here's my leftmost point, 1, 2. So I've got to do one more. What's the next number we can take the square root of nicely? 9. All right, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And the square root of 9 is 3. And it looks like this. Why don't I have any numbers on the left? I can't take the square root of a negative number. Perfect. We end up in the complex plane. Perfect. Love it. Is it nice to have these marked over 1, up 1? And then this one is 4, 2. And this one is 9, 3. Okay, what does the minus 3 do? To the down, yep. And our 2 is going to stretch the y. So multiply y by 2. All right, let's move it down 3. 1, 2, 3. We would be going over 1, up 1. So we've got to do 1 times 2. Over 1, up 2. Over 4, up 2 times 2 is 4. I feel like I need to remind you when I'm going over, it's always from that initial point. Don't ever start counting from the next point you've graphed. Always go back to that original vertex. And then we're going to go over 9, up 3 times 2, which is 6. Over 9, 1, 2, 3, 4, 5, 6. And then we connect those dots. You'll just click on the Graph It button. Love it. Did we ever cover this function last year? Yeah. We did? I couldn't remember. I'm going to point out on this one, we don't have to, but I'm going to point out this is the parent function. So this is the x cubed parent function. And its key points are this 0, 0. And then we're over 1, up 1, but we are over 1, down 1 as well. And then your next number, if I'm to square 2, what is it? Not squared, cube. If I'm to cube 2, what is it? 8. So that's your next point up here. So there's our 2, 8. And then down here is our negative 2, 8. Those are your parent function points. because chances are you might get one of those you need to graph. So they've given this function to us, and in ALEKS, you're just going to be able to drag it. You'll just move it up and down. But what am I going to do here? This one goes up 2 and left 3. So I'm just going to take all of those points that I just graphed, and I am going to go up 2, left 3. 1, 2, 3. Up 2, left 3. Up 2, left 3. Left 3. Up 2, left 3. And again, you'll just be able to, whoa, that needs to be really big. I struggle. You'll just be able to drag it. All right, you guys were fast at that one. I'm wondering if I want to save that for the end, because I'm going to show you in ALEKS. Nah, we can do it here. Okay, remember that 4-line entry that I said you're going to want this? Right here. So let's keep it, I'll rip mine open so we can see it. Where is it? There it is. If you don't do it in the right order, you're going to miss these. So they're going to give us some random function, and they say, okay, do all of these operations. Now, you guys know that this moves up, and then what does this do? It's going to flip it upside down, right? Now, which one of those do you do first? Which one? So vertical shift, that up, is all the way at step 4, right? So I need to flip it first. Now, this is how ALEKS recommends doing it. So if I'm flipping it across the y-axis, wouldn't these stay here? And then wouldn't this move here? Okay, ALEKS really recommends plotting those points, just as a guide. Don't connect any dots, but we've done the first translation, right? That was our step 1. And then what do we need to do to all of those points? Now I can move them 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Then you will connect those with the segment, and you do have to go back and erase those initial guide points. Half of the battle is understanding which order you go in on those. Questions on that one? You guys have questions, you're just not asking. We're good? Speaking for the class, I appreciate that. Love it. Do you want to try this one on your own? Not really? Okay, let's start here. What does this one do? This is left. What does this do? That stretches our vertical, so it stretches our y, right? So which one does it say we do first? Horizontal shift is first. So look at these endpoints. See all these endpoints? I'm going to shift them all which way? Left one. So there's our guide. All right. And then what does this 2 do? So it's going to multiply all of our y's, right? So here our y is what? 4. So times it by 2. 8. Here our y is it? 0. So 0 times 2 is, so it stays there. Here your y is 2, so 2 times 2 is 4. There you go. Use your segment connector. That's an awesome straight line. Remember to go back and erase the points you don't need. These steps are your best friend on those problems, okay? All right. Hopefully this one is friendly-ish. Here's our absolute value function. What's going to happen to it? You're just going to drag it where? Down 3 and left 4. So down 3, left 4. There it is. And this one's just rude. Yeah. You're going to have to use your point plotter on something like this. Do you remember what our parent function points were?
1, 0.
We had 0, 0. We had 1, 1. So then we had -1, -1. And then we had 2 what?
8,
And then we had, good. Oh, Landy. So this -5/8 multiplies what? Your y direction, right? Okay. So the 0, 0 is easy. Oh, gosh. That's so rude. So we're going to go, oh, let's talk about this. This is what our parent function looked like. I didn't notice it was negative, and I was so focused on the fraction. What does the negative make it look like? So it's going to go this way, right? Negative slope? We wish, right? We wish it was staying here. So we're moving in the opposite direction. So we're going to go over 1, and then it would be down. We've got 1 times 5/8, which is 5/8. So you'll have to type that in. So we'll have it here, and we'll have it here. That's so gross. And then our up or down 8 is 8 times 5/8, which is just 5. So over to 1, 2, 3, 4, I think that's 5 right there. And then on the other side, that's 5. Okay.
Wait, why is it 8?
Ah, okay, because if I plugged in 2, 2 cubed is 8. That's a really good question. And again, if you hate the parent function moving it around, is there any problem with plotting points like this? Taking your values and plugging them in. Nothing wrong. Okay? That's a great way to do it. In fact, if you talk to me and say, Mrs. Yates, I hate moving the parent function, will you please spend some time with me on a table? I'd be happy to. Okay? As if that lesson wasn't big and deep enough, 2-7 is some new stuff. Symmetric. Symmetry. We are going to, and once you get the hang of this, this is friendly. When we're talking about symmetry, we are in relation to the x-axis, the y-axis, and the origin. So symmetric to the y-axis, symmetric to the x-axis, symmetric to the origin. was hoping we had some visual ones in this packet, but it doesn't look like we do. You don't need to take notes on this. This is just to help kind of prepare us for what it is. So our parabola, use your imagination. Pretend I did balance that on that axis right there. Does this have symmetry? In regard to what? The y-axis. All right. What about this function? Use your imagination. That's actually a pretty decent circle. So it's x and y and the origin. So what does symmetric on the x-axis look like? Something like that? Okay, so this is kind of how I like to think about it. If I can fold it left to right, like closing a book, so close a book, it's symmetric on the y-axis. How about this one? Close a newspaper, fold a newspaper. Okay, we'll go with that. Fold newspaper. So that would be from the top down, right? That's on the x. And this one, I kind of pretend like I'm folding a note. If I can fold it in half sideways and then in half from the top, and it's all centered on that one little corner, then I know it's on the origin. All right? So that's visual, and you will have some of those in your homework. I don't know why I don't have them in the packet. But then we have tests. Substitute in negative x. So if it's on the y-axis, I'll do this with you, by the way. Substitute in negative y. And this one is substitute in negative x and negative y. So we've got a little bit of work, and I don't have a whole lot of room, so I'm going to grab my pencil right here so I can write smaller. I'll zoom in though. Keep that handy. That's what I'm going to be referring to, even though you can't see it. Okay, so we're going to do algebraic tests of symmetry, and we need to decide which. If I want to see if it's symmetric on the x-axis, come back up here, what do I do?
Substituting negative y.
Substitute in negative y for y. All right, so I'm going to go negative y equals x squared minus 8. I should write that right here. I'm going to write it right here because that's where we're doing it. I'm going to simplify everything I can. Negative x squared plus 8. I really didn't need to do that, but are those equations equivalent? The one we started with and the one we simplified. So that's why this one is a no. For the y-axis, what do we do? Negative x, so we've got y equals negative x squared minus 8. So then I get y equals x squared minus 8. Do those match?
Yes.
That's why this one is a yes. Go ahead and ask. I would love for you to ask.
I'm just confused how we got negative to positive.
I was kinda
Squaring a
like-
negative. On above it,
Oh.
because it's in parentheses. Yep, we're squaring that negative.
Okay.
All right. Origin, I replace a negative y and a negative x. What do you guys know without me simplifying this any further?
We can't.
They're not going to match, so that's why this one is a no. Should we do that one more time? One more time. Symmetric on the x-axis, what do we do? Negative y equals negative 2 times x cubed minus 8. What's going to happen if I divide everything by negative? It doesn't match the original, right? No. For the y-axis, what do I substitute in?
Negative x.
Negative 2, negative x. The cubed is on the outside, minus 8. What is a negative x cubed?
It's still negative.
Negative.
So I'm going to have a positive 2x cubed.
So then,
So that one's a no.
so it's
Let's try the origin. What do I do? Both of them. Negative 2, negative x cubed, minus 8. So I know this is going to be a 2x cubed minus 8. But what happens when I divide by that negative? I get the wrong sign on that 8, don't I?
Yeah.
So this is a no. So that's why it's none of these.
So if it's a no on even one of the axes, it can't be the origin.
Right. Yep.
So it's just one of them almonds.
Mm,
There's a dollar.
It could be all, if you get one, you should check the other.
Yeah, check. That's the fill. Yes, check.
It could be all of them.
It could be, except for none of these, right? It could be all three. Yeah, could be all three. I think now we're in a little bit lighter stuff, so stick with me for just a second and I'll remind you how to do this. Here we've got our function, and I've got a piecewise function. It's in pieces, right? I just need to remind you how this works. If it wants us to find when x is negative 1.5, I'm going to come over here and I'm going to look at these parameters, right? Where does x equals negative 1.5 fit? Just this first one, right? Now, this is always confusing because when I look over here, there's not a variable, right? If it had negative 2x, what would we do? We'd substitute it in. But it's just negative 2. So guess what it is? It's just negative 2. All right, where is x negative 1.2? Right here, if it's in this one? So it is, it's just negative 1. And where is it 0.5?
1.
Here? Okay, so do we remember how to do piecewise functions? Yay! Look at this! Increasing, constant, or decreasing? How about right here? How about here? Here. 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 Oh, you guys are so good. Relative extrema. We're talking about maxima and minima, okay? You are looking, when it says the word local, you are looking for valleys and peaks. Because if it asks just for the maximum, wouldn't that be, yeah, infinity? Now, pay attention in your homework on these two questions right here, A and B, because Alex is mean and it flips those back and forth. It doesn't always type them in the same order. One of them refers to the x, one of them refers to the y. So our job really quick is to figure out which is which. So all values at which g has a local maximum. Is that an x or a y? X. That's definitely an x. All local maximum values are y. So where do we have a local maximum? So it would be negative 1 and 3. Okay. All local maximums of g, 2 and 2. So I'm just going to type 2. Did we graph piecewise functions? I don't feel like we did. What does this line look like? I know this is a big lesson. I'm sorry. It really is. What does this line look like? Right? How about that one? And that one? And that one? If this is a piecewise function, we're going to have how many pieces of lines? 4. You do need to pay attention to your inequalities, your closed dots and your open dots to get this right. Okay, so let's start right here. Negative 2 is down here. But my x values, I'm in between what and what? -2 and -1, which would be here. And I did them both open just because I didn't check. The -1 one is closed. All right, the -1 is here, but I'm in between what? -1 and 0. Goodness gracious. And the right one is closed.
Yep.
And then 0 is here in between. Oh, now you should feel the pattern, you guys. This is a fancy piecewise function called a step function. I wonder why. I'll give you a second longer on that one. Last one, we have arrived, we have arrived, we have arrived. We've got two pieces. This is part of what? This one's part of a parabola. This one's part of what? Part of a line. I am going to, by hand, show you how the ALEKS tool works instead of pulling it up, just so I don't take more of your time. Help me graph this guy. Parabola, we're going to go up how far? 10. And then it's negative, so we're going to go upside down, over 1, down 1, over 2, down 1, 2, 3, 4. And you have your parabola. And then ALEKS has this nifty button over here that looks like scissors. Those are amazing scissors. Don't judge me. And we have to cut off the piece of the parabola that doesn't work. Because where are we supposed to be? I guess I should make this continue. Your parabola will continue. Where does it fit? Only in between x is -4 and 4. So that is this spot and this spot. That would go over there if I had. Right? So I need you guys to help me though. Are those spots going to be filled in or closed? So this one is closed and then this one is open? You're going to grab that scissor tool and you'll click here and here after you plot those points. And it will cut those off. They will magically disappear. If I knew where my big eraser is, I would use it. So they will go away. And then where does our line start? At 4. So it's what? Up 6? 1, 2, 3, 4, 5, 6. And then it's down 3 over 1. And so it would look like this. That's so straight. Where does it start? Where does it start existing? You're right. Only if what?
X is greater than or equal to 4.
So right here?
Yeah.
So 4, I come down to my function. And then what are you going to grab? The scissors. And you're going to cut off the piece that doesn't exist. So then I've got this nifty closed, open, and then you have your line going down from there. That's a big lesson. It is, it is, it is. And it's in your test on Friday. So really, really, really make sure you